What is a derivative function? Finding the derivative is the question that we want to answer in Calculus 1. But what is a derivative function? So before we talk about derivative, we need to understand two concepts. What is a secant line and what is a tangent line? A secant line is a line that touches a curve at least 2 points. For example, in the graph, I have point Q and point P. And the line in purple touches these 2 points on this curve. So the purple line is the secant line. And a tangent line is similar to a secant line, but the 2 points are really close to each other. So instead of Q and P, now we want to move one of these points really close to the other point. So we get a point that is right next to Q, and let's call this point P prime. So the tangent line at point Q is the line that passes through Q and P prime. So the purple line is the secant line, and the line in red is the tangent line. In general, for a linear function, y equals to mx plus b, the slope of the line is denoted by the m. To find the slope, we need 2 points on the line, and the slope is defined as y2 minus y1 over x2 minus x1, which is the change in y over the change in x. So now what is the slope of the secant line, and what is the slope of the tangent line? So let's put these 2 points in a more general case. Instead of the coordinates x1, y1 and x2, y2, we put it as x, and the other point is x plus h. So the change in x is h. So the slope of the secant line would be the change in y over the change in x, which is h. So y2 minus y1 would be f of x plus h, the second point, minus the first point, f of x, over the change in x. Now what's the slope of the tangent line? So remember that a tangent line is similar to a secant line, but the 2 points are really close to each other. So now we want to move the second point, the x plus h, really close to x. It also means that we want the h to be really small. Using the limit, we can define the slope of the tangent line as limit as h approaches 0 of the slope of the secant line, which is f of x plus h minus f of x over h. And this is the definition of the derivative function. A derivative function is actually telling you the association of the slope of the tangent line to the x value. We denote the derivative function to the function f of x as f prime. So the prime means the derivative. So by the definition, the derivative of the function equals to limit as h approaches 0 of the slope of the secant line, which is f of x plus h minus f of x, the change in y, over the change in x, which is h. Now let's look at this example. Consider f of x equals to x squared. Now we want to find the derivative function, f prime. So we start with the definition of the derivative function. Limit as h approaches 0 of f of x plus h minus f of x over h equals limit as h approaches 0. So for this function, f of x plus h is x plus h squared minus the function f of x, which is x squared, over h. So if we use the cheating rule, we'll get x plus 0 squared minus x squared over 0. The x squared minus x squared is 0. So if we use the chain rule here, we'll get 0 over 0, which is inconclusive. So now let's try to simplify the function, and we expand the numerator. So this equals to limit as h approaches 0. We expand the square to get x squared plus 2xh plus h squared. Then minus x squared over h. So this x squared cancels out with this negative x squared. And we can factor out an h in the numerator and cancel out with the h in the denominator. So this limit is 2x plus h. Now we use the chain rule again. We substitute h by 0 and we get 2x. So it means that for the function x squared, the derivative function is 2x. We can actually find a more general form. If we have function that equals to x to the power of r, where r is any real fixed number, then its derivative function is r times x to the power of r minus 1. In this formula, we call it the power rule. Using the definition of derivative function, we can actually derive a lot of formulas. For example, the one I just mentioned. If y equals to x to the power of r, then its derivative is r times x to the power of r minus 1. And using the definition of derivative function, we can also derive the derivative for trigonometric functions, for log function, and for exponential functions. So in this video, we just covered the definition of derivative function. If you have any questions, please comment it below, and I'll see you in the next video.